physical chemistry, that is hardcore 103. This is the first semester study material where we are going to study the fundamentals of thermodynamics and fundamentals of chemical kinetics. This is the block one where I'm going to discuss that is fundamentals of thermodynamics and fundamentals of chemical kinetics. This is the block one and block two. Fast, I hope it is audible, right?
Yes, sir.
So, in the first block, we are going to study the basic details of means basic fundamentals of thermodynamics and what are the terms used in thermodynamics and introduction to first, second law and third law of thermodynamics and variations of energies, Maxwell's law, distribution law, and also Gibbs theme equations we'll be studying. So basically, we should know what is thermodynamics. It is the branch of science which deals with energy in a system. So whatever the reaction taking place inside the system means a system is nothing but a closed system, or it may be a open system which is not having direct contact with the external surroundings. So inside a system we are going to study the reaction with varying the temperature, pressure. So this
Volume.
reaction, volume, these reactions we are going to study in that. So thermodynamics is a branch of science which deals with the energy. So it is the relationship between the system and the surroundings we are going to study in that. So in that we are going to study zeroth law, first law and second law, and also enthalpy and entropy. So enthalpy and entropy, you should be knowing the basic differences. All the terms I will be explaining in this class. So some of the terms used in the thermodynamics andre isolated system, open system, and closed system. We are going to study different reaction taking place in the each system. So the thermodynamics is the study of energy, the energy transformation, and its relationship inside the box or a system. So there are three laws, that is first law, second law, and third law of thermodynamics. So we are going to study the different variables and enthalpy change, entropy change by varying different temperature, volume, pressure. We are going to study each state of the system. So some of the basics terms used in the thermodynamics are system, surroundings, boundary, pressure, state, and also with respect to equilibrium. So these are the basic terms we are going to use in the thermodynamics. So one more thing I should say, important thing under each unit they will be having some of the important questions. You should go through this. In the whole syllabus you can't read also. At least you should go through this important questions in each unit for getting a good score. So explaining the important terms of thermodynamics, understanding the law of thermodynamics, explain the significance of entropy, enthalpy in the study of thermodynamics, and derive the relationship between the entropy and free energy, difference between the spontaneous and non-spontaneous process, means whether the reaction is taking spontaneously or not, that we are going to study in this, deriving the relationship between free energy and spontaneous process. These are the important things which you should go through this unit. So coming to the system, a quantity of matter or a region in a space, the portion is to be studied. So in each, yes, this is the system which is not having the contact with the surrounding. Means it is in the closed system. The system may be a closed or isolated system or open system. Whether the reaction it's not influencing the external surroundings. So this is the system. So when it isolated system means a system which can exchange neither energy nor matter. So this is known as isolated system. And open system andre a system which can exchange both energy and matter. So that is known as open system. And closed system andre it cannot exchange whether energy or a matter. That is
Matter.
the closed system. So this is with respect to systems. Uh, these are the basic terms which are going to use in the further things. And here one more thing that is important is homogeneous system and heterogeneous system. So this is with respect to isolated, closed, and this is isolated, open system, and closed system. So here in isolated, energy or matter cannot be exchanged. In open system, energy and matter can be exchanged with the surrounding. And a closed system only, no energy or matter can be exchanged. So coming to the homogeneous system, a system is said to be homogeneous when it is completely uniform throughout, so it is equally distributed. So when the chemical composition or physical properties are same in all the part of the system, means equally distributed inside the system, that is known as homogeneous system. In heterogeneous system, when a system is not uniform throughout the system, means throughout inside the system it is not uniformly distributed, so that can be known as heterogeneous system. So water with ice floating on its example can be denoted as heterogeneous system. Heterogeneous system gave water, and then some of them it is not equally distributed inside the system Allah. Some part of the water it may be in the ice and some part of it is in the liquid form, solid and liquid form. So the solid form is ice and liquid will be in the water. So this can be given a taken as an example for heterogeneous system. So next, state functions are state properties. So for example, uh, a reaction is taking place under whatever the energy released or whatever the pressure created and the volume increased or decreased, the temperature increased or decreased, we can be studied inside the system. This is known as state functions or state variables. So the measure of property is required to describe the state of a system. So that is state variables. For state variables andre that can be denoted as pressure, temperature, volume, mass. These are known as state variables. Means it can be varied. For example, one reaction is taking place under from the external source, the pressure can be increased or decreased for the reaction to complete. Whether the ಈಗ temperature increase ಮಾಡಿದಾಗ some of the reaction will be proceeds faster. So when the temperature is decreased, the reaction may slower the process. So this will be taking depending on the pressure, temperature, volume, and also with respective mass of the reactants what we have taken. So the properties which are associated with collective behavior of particles, such as macroscopic system, and also with respect to composition, density, and also refractive index. So these are the state variables, and state variables are of two types, that is independent variables and dependent variables. So which depends on the variable is called dependent variables. Extensive based on the system, such as extensive variables, intensive variables, specific variables. These are the dependent variables, where extensive variables ಅಂದ್ರೆ volume, mass, energy. These are the extensive variables. So intensive variables andre mass and volume are extensive variable, where density becomes intensive variables. Intensive variables ke only with respect to density. And also the state function. The state function is a property of the system whose value depends on only on the state of the system. So if you go through these terms, you will get to know what is variables ಅಂದ್ರೆ ಏನು variables ಅಲ್ಲಿ what are we call it as variables: pressure, volume, temperature, internal energy. These are the variables, how it can be varied, and intensive variables, extensive variables, also with respect to state variables. And also coming to the state functions andre, for example, pressure, volume, temperature, internal energy, enthalpy. The state function is a property of the system whose value depends only on the state of the system. So a value, it depends only on the state of a system. When the reaction is taking place inside the system, A forming the product B inside the system, by varying pressure, volume, temperature, also with respect to internal energy and enthalpy, we are going to study the reaction, whether the reaction is taking place faster or slower. So before getting, and one more term important ಇದರಲ್ಲಿ ಅಂದ್ರೆ entropy and enthalpy. Entropy is denoted by S, and enthalpy is denoted by H. So entropy is a measure of amount of disorderness in the system. Whatever the variations, disorderness taking place inside the system, that is denoted as entropy. And enthalpy andre the measure of energy in the thermodynamic system. So whatever the energy created or destroyed inside the system, that can be denoted as enthalpy. Enthalpy can be denoted by H.
H.
So next is the state of a system. So a state of a system is defined as state variables. So here same state variables under pressure, temperature, volume, mass. These are the important state variables used for defining a system. A system consists of a large number of particles, for example atoms, molecules. The reactant andre ಇನ್ನೇನು, what we are taking some chemicals such as atoms, molecules to form the other products. So with respect to atoms, molecules. So if you choose whole system to study at a time, then it is called one second. A state of a system is defined as a state variables. State variables are nothing but pressure, temperature, volume, mass, and composition. So some of the important variables used in the defining a system. A system, if you choose a whole system to study at a time, this is called as macroscopic system. One second. One second. Yes. Uh, State variables are nothing but pressure, temperature, volume, mass, and composition. So important. These are the important state variable used to define a system. So next term is thermodynamic equilibrium. In this thermodynamic equilibrium, a system in which a macroscopic properties do not undergo any changes with respect to time is said to be thermodynamic equilibrium. So there will be no changes taking place whether the uh, with respect to temperature and the work, and also with respect to reaction taking place. So here we can be, it is of three types, that is thermal equilibrium, mechanical equilibrium, and chemical equilibrium. In if there is no flow of heat from one portion to other portion of a system, that is thermal equilibrium. And also with respect to mechanical equilibrium, andre a system is said to be mechanical equilibrium if there is no mechanical work done on the part of the system, and the other part of the system. So there will be no mechanical work. So that can be called as mechanical equilibrium. And also with respect to chemical equilibrium, there is no, the composition of various phases of the system remains equilibrium, means there is no reaction taking place inside the system. So that is known as chemical equilibrium. So this can also be denoted as process. Either taking places can be denoted as process. A system undergoes from one equilibrium state to another equilibrium state, that is known as process. There will be of two different paths that can be denoted here, that from state 1 to state 2. Some from A taking place to B. So it can be of different path depending on the variation of the state variables. ಈಗ ರಿಯಾಕ್ಷನ್ ಎ ಇರೋದು ಬಿ ಪ್ರಾಡಕ್ಟ್ ಬಿ ಫಾರ್ಮ್ ಆಗಬೇಕು ಅಂದ್ರೆ ಬೈ ವೇರಿಂಗ್ ಟೆಂಪರೇಚರ್, ಬೈ ವೇರಿಂಗ್ ಪ್ರೆಷರ್, ವಾಲ್ಯೂಮ್, it can take different paths for forming the product depending on the variations of state variables, means pressure, temperature. It may, for some, for example, if you increase the reaction temperature, it may, the product form will be sooner, means time taking process will be faster. So some of the temperature is reduced, the reaction completion of reaction may be slower. So depending on the variation of state variables, the formation of the product, it varies. So that is what the process here. The system undergoes from one equilibrium state to another equilibrium state is known as process. A process is complete defined by mentioning initial and final state of the path. So it may take A path or also may take B path depending on the state variables. So here there are different types of process, that is isothermal process. In isothermal process, the temperature is kept constant. So it is a process in which temperature of the system remains constant. Whatever the temperature, it is not increase or decrease inside the system. It is that is the isothermal process. Adiabatic process andre thermally insulated from the surroundings. Means thermally insulated means if there is no interaction between or contact between the surrounding with respect to system. And isobaric process andre isobaric process means the pressure remains constant. The pressure is kept constant. There is no variation in the pressure. That is the isobaric process. And isochronic process andre volume remains constant. Volume it's nothing but the whatever the reactants we are taken, we are not increasing or decreasing the volume. So we have kept the reactants volume constant. That is the isochoric process. And cyclic process and the process which brings back to the initial state. So that can be reversible reaction. That is the cyclic process. And reversible process andre reversible process is one in which all changes occurring in any part of the process and exactly reversed when it is carried out by the opposite direction. From A forms the product B andre, then B can be forms the further in the further reaction it can form product A. That is the reversible process. And in irreversible process andre that cannot be formation of the initial reactant state. It cannot be formed. So these are the changes of state in a process. And next is the steady state. So these are the different variations taking place where in isochronic V is kept constant volume, that is, and in isobaric pressure is kept constant. In isothermal temperature is kept constant. In isotropic S is kept constant. So that is S is nothing but the entropy. So what is entropy? Enthalpy and entropy should know. We should be knowing the basic difference between the entropy and enthalpy. Entropy is the measure of amount of disorderness in a system, that is denoted by S. And enthalpy is the measure of energy in a system. So that is denoted by
H,
H.
H.
So here, what are the conditions we are putting for isochoric, isobaric, and isothermal and isotropic? We can see the result. That is the dV is equal to 0. Volume is kept constant. dP is equal to whatever we have kept constant. There will be no variation. So that is the reason it will be all will be in the 0. And pressure by temperature is constant. Volume by temperature also will be in constant, and pressure into volume, that is constant. So next you are going to steady state. So in steady state, the process in which the properties of a system are independent of time is called as steady state. The variables of a system may be of mass, energy remains unchanged with respect to of this process. So here the variables such as system, such as mass and energy remains unchanged. So that is the steady state. So next we are going to discuss how the work is taking place in the thermodynamics. So yeah, a system change from one state to another state, a complaint by changing energy. So in this system, the piston is moving outwards. So whatever the energy, it can be released after a reaction is taking place. So this in this system, the change from one state to another state. The state of a piston is moving from A to B. So the changes it can be seen in the block diagram. So here the work done when resistance of 1 Newton is moved throughout the distance. So it can be written as J is equal to N M. So J is nothing but the joule and N is the Newton meters. So it can be SI unit of energy is joule. So J is equal to N M.
NM.
So that can be Newton meters. So Joel showed that definition relationship between mechanical work done and heat procedure. So whatever the work done is inversely proportional to the heat. So here it is known as or W is equal to JH. This the work is inversely proportional to the heat or produced whatever the heat. ಅಂದ್ರೆ ಈಗ work complete ಆಗಿದೆ ಅಂದ್ರೆ heat will be produced ಅಲ್ಲ. So when the reaction is completed, the heat will be produced. So work is inversely proportional to the heat produced. So J is known as joule mechanical equivalent, and for one equivalent that can be 4.184 joules, or 1 calorie is equal to 4.184 joules. Work is defined as the energy transfer into a system through the change of an external parameter. That is, external parameter is nothing but the piston moving outside. If the work is done andre, from the piston it will be moving from A to B. So that is the active area of the piston. This A is denoted as active area of the system. So here what process it is taking place? DX andre, it is in the reversible transformation. So it is moving outwards ala.
Pressure.
Whatever the reversible transformation taking place. So A is the active area of the piston and P is the pressure and F is denoted as force. Here for the dV is equal to A dx. dV is nothing but the volume kept constant and A dx is the reversible transformation. This is the reversible transformation. So F is equal to minus PA. F is the force and P is denoted as the pressure. A is the active area of the piston. So to calculate the force, you are going to pressure into active area of the piston you are going to calculate. So next delta W is equal to F dx minus is equal to minus PdV. So delta W is the work done here is equal to minus pressure into A dx. That is the equation 1. So the total work performed it can be denoted as delta W is minus V1 V2 integral of V1 by pressure into delta V. So volume ಅಂದ್ರೆ V1 to V2 whatever the movement of the piston is taking place that can be taken the values to calculate the work done inside the system. So when the reaction is taking place inside the system, the piston moves outwards. Whatever the work done inside the system, it can be calculated using delta W is equal to minus integral of V1 to V2 into P dV. So P is the pressure, V is the volume.
Volume.
The sign of the work is depends on the type of procedure done. So compression or expansion, it can be denoted here. The expansion is taking place. So expansion andre work on the piston is positive and work on the gas is negative. So expansion ಆಗ್ತಿದೆ ಅಲ್ವಾ ಇಲ್ಲಿ piston is moving outward. So work on the piston is positive. It can be denoted by plus and work on the gas. Means gas is expanding. So it is in the negative state. So for compression, the work on the piston is in negative. It comes inwards. The piston moves inwards and see piston moves inwards andre out first. In the first block diagram you can see there expansion means the piston is moving outwards. Work on the piston is positive and the work on the gas is in negative. So the piston is moving outwards. That is known as expansion. And in the compression, work on the piston is negative and the work on the gas is in positive. That can be seen in this two block diagram. So next is the heat of the thermodynamics. These are the basic concepts, basic things what you should be knowing before deriving the equations in the further topics. So heat of the thermodynamics andre the energy is transferred in a system or it can be liberated or absorbed by the system. So heat of the thermodynamics you are going to study energy is transferred in a system in the form of heat when no mechanical work is done. So heat of the system when there is no work is taking place inside the system, the energy can be transferred in a system. So the transfer of energy from A to B is the heat. So here temperature of A respect to temperature of B. The the transfer of energy from A to B. Andre temperature andre only heat can be passed from A to B. That is the heat of a thermodynamics. So next is the heat capacity. Heat capacity andre it is the system absorbed the amount of heat liberated means whatever the term heat liberated that can be absorbed by the system that is known as heat capacity that can be denoted as delta Q. Delta Q is inversely proportional to delta T andre when the temperature is increased the heat capacity also decreases increases. So delta Q is equal to C delta T. C is proportionally constant and the heat capacity of the substance. So when the heat capacity varies with temperature, the value of C, that is heat capacity, also considered a very narrow
Very.
temperature range. So there'll be much differences. So heat capacity at constant volume that can be denoted as CV and heat capacity at constant pressure that can be denoted as Cp. So here the heat supplied to a system by raising 1 degree, keeping volume as constant. Means whatever the reactants we are taken that is kept constant. Only we are varying the temperature that is with respect to constant volume. CV. Constant pressure andre we are keeping pressure constant and varying the temperature. So that is with respect to heat capacity with respect to volume and pressure. Heat capacity with respect to volume and pressure andre that is CV and CP. We are increasing the temperature of a system but keeping volume constant. Volume ಯಾವ್ದು constant ಇರ್ತೀವಿ. Whatever the reaction or reactants we are taken to form the product, that volume will be kept constant. And also in the next one more, CP andre will keeping pressure will be
Pressure
kept constant
constant.
when the temperature is increased by varying 1 degree Celsius. So this is with respect to CP and CV. So these are the uh, basic terms what we are going to study. And coming to zeroth law of thermodynamics. In the zeroth law of thermodynamics, when A is in equilibrium with B and B is in equilibrium with C and C will be in equilibrium of A. So the same thing here. If a body A is equilibrium with body C and body B is also equilibrium with body C, then two bodies of A and B are also in the equilibrium state. So that is what A is equilibrium with C andre and C is equilibrium with B andre. Generally A and B also will be in the equilibrium state. This is the zeroth law of thermodynamics. So next is the first law of thermodynamics. Here energy can neither be created nor it can be destroyed, although it can be transferred from one state to another state. So energy can neither be created or it can be destroyed. It can be transferred from one state to another state. So this is the first law of thermodynamics. And next is the mathematical formula for first law of thermodynamics. Here delta E is equal to Q minus W. Q delta E andre that is the internal energy. E represent energy. Q represent the quantity of heat. W represent the work done by the system. So these are the basic terms we should be knowing. Delta E andre that is the energy.
G.
Whatever the variations in energy, it can be represented as delta E. E andre energy and delta E andre whatever the variations,
Internal energy.
internal energy. That is what E2 minus E1, whatever the product, ಈಗ reactant in the product form ಆದಾಗ, whatever the internal energy. Internal energy is nothing but the system's energy surrounding the la. Whatever the system energy is known as internal energy. So here negative heat is evolved by the system, the energy that is in the negative state, and positive heat is absorbed by the system, that is with respect to energy. The with respect to work andre positive work is done by the system and negative work is done on the system. So here if come to the graphic diagram, here in the surrounding environment, this is the system with respect to surrounding environment. So here Q is the quantity of heat. Q is greater than 0 andre heat is positive when it enters the system. Means heat enters the system andre Q is nothing but the quantity of heat.
Heat.
So W is the work and
Work done.
work done and delta E is the internal
Internal energy.
energy. So heat is the positive when it enters the system and W is greater than 0 andre work is also in the positive state. So work is done by the system. Same thing when heat is in negative, when it leaves the system, means it will be absorbed by the system so whatever the heat liberated or it will be of less So it will be of negative state. So it is in negative when it leaves the system, and work is in negative when it is done on the system. So here the environment with the system is Q is less than 0 and W is less than 0. W is the work and Q is the quantity of heat. So next is the enthalpy of heat content. Enthalpy andre it is denoted by H. It is the measure
H.
of energy of the system, thermodynamic system. Whatever the energy liberated, it can be measured. So it is known as enthalpy. So heat content, the total heat content of a system at constant pressure is equal to the sum of internal energy. The total heat content of a system at constant pressure is equal to the sum of internal energy. So here H is equal to E plus PV. H is the enthalpy of the system
Enthalpy.
and E is the
Internal
energy
energy.
and P is the pressure and V is
Pressure.
the volume of the
Volume.
system. So this can be studied using this equation H is equal to E plus PV. To know the enthalpy of the system,
Enthalpy.
H is equal to should be calculating using energy, pressure, and volume of the system. That is the equation 3. So where P and V are pressure and volume of the system, it can be kept constant, and also change in enthalpy means when the enthalpy is varied, enthalpy of the product minus reactant. ಈಗ ಎಂಥಾಲ್ಪಿ heat content change ಆಗುತ್ತೆ ಅಂದ್ರೆ ಹೆಂಗ್ how it may when the product is formed from the reactant, the enthalpy will vary. For example, A to B, the product has formed. Whatever the changes in this reaction means it is liberated or it is absorbed by the
Consumed.
system. It can be studied here. So to study that change in enthalpy, that is change in enthalpy is equal to enthalpy of the product minus enthalpy of the reactant.
Reactant.
So ಮೇಡಮ್ ಎಲ್ಲ ಬೇರೆಯವ್ರಿಗೆ ಅರ್ಥ ಆಗಲ್ಲ ಪ್ಲೀಸ್. And delta H is equal to H2 minus H1. H2 and H1, H2 is the enthalpy of the product and H1 is the enthalpy of the reactants. Whatever the initial state reactants what we have taken, that can be denoted as H1 here. In the equation 4, H2 and H1 anta ಇದೆಯಲ್ಲ, H1 is the enthalpy of the reactants in the initial state. H2 is the enthalpy of the product formed. Enthalpy is nothing but the heat liberated by the measure of energy in the system's thermodynamic. So whatever the enthalpy I need to calculate the system internal energy and the potential of its pressure with respect to volume. So here it can be denoted as delta H is equal to H2 minus H1, where H1 and H2 are enthalpy of the state 1 and state 2 system. State 1 and state 2 andre from the reactant to product. So H1 is equal to E1 plus PV1 and H2 is equal to E2 plus PV2. So H1 and H2 andre H1 can be denoted as A side and H2 can be denoted in the of B side. So when enthalpy is varying, even the pressure volume also varies from the reacted in the product form ಆಗ್ಬೇಕಾದ್ರೆ even the pressure volume temperature everything will be varied, that should be measured. ಅದನ್ನ measure ಮಾಡಿ we are going to insert this value in this equation E1 PV1 E2 PV2. In that place we are going to replace with the values of that system ಅಲ್ಲಿ ಎಷ್ಟಿದೆ measure ಮಾಡಿ we are going to insert the value so that we can calculate the enthalpy of the system, whatever the changes taking place when the reaction is taking place inside the system. And next is the mathematical representation of heat capacity. So here the heat capacity of a system is defined as the amount of heat required to raise the temperature. Heat and capacity andre whatever the amount heat required to raising the temperature. When the temperature is raised, the heat of the system also increases by 1 degree. So it can be denoted by C. C is the heat capacity of the system. So it can be represented in the equation C is equal to d cube by dt from the first law of thermodynamics, where dq is equal to dE plus PdV. So dq andre the quantity of heat. This dq is nothing but the quantity of heat, and E is the energy of the system, and pressure P dV, pressure and volume of the system. So substituting dq in the equation 6, this is the equation dq value. If you substitute, we get an equation C is equal to, that is heat capacity. C is equal to dE plus PdV by delta T. So that is the equation 7. To calculate the heat capacity, we are going to use this equation. C is equal to delta E by delta T plus PdV, or delta E plus PdV by delta T. That is the equation 7 we are going to use for calculating the heat capacity of a system. So here also whatever heat capacity ಆಗಿರ್ಬೋದು, ಎನರ್ಜಿ ಆಗಿರ್ಬೋದು, ಎಂಥಾಲ್ಪಿ ಆಗಿರ್ಬೋದು, ಎಂಟ್ರೋಪಿ ಇರ್ಬೋದು, by varying pressure volume we'll get a different equation. So ಈಗ generally we have got equation, this equation 7 for heat capacity. So same thing we are going to calculate heat capacity with keeping volume constant. Volume andre the reactant volume will be kept constant. We are going to vary the heat capacity. So that the same equation 8 we have taken by keeping, you know, pressure constant andre for heat capacity we are going to get the value, that is the 10 H is equal to E plus PV, where we are going to insert the values of H E plus PV. H is equal to dH by d delta T with respect to P. Andre P is kept constant. CP ಅಂತ ಎಲ್ಲಿ ಬರುತ್ತೆ, that is the constant pressure. Constant pressure always it will be 0. So with respect to pressure we are going to derive the equation for heat capacity, that is Cp is equal to delta H by delta T with respect to pressure. That is the equation 12. So here constant pressure represents the specific heat of a constant pressure. So when delta H means enthalpy is varied, delta temperature of the temperature also changes. So next is the relationship between constant pressure and constant volume. So here to derive by varying different terms, we are going to derive an equations in, that's all with respect to thermodynamics. For whatever the basic things I have told till now, Those are the basic things. System, we are going to study the temperature, pressure, volume, heat capacity, enthalpy, that we are going to study by uh, putting an reaction. By one reaction ತಗೊಂತೀವಿ by varying the temperature, pressure, volume, and also volume of that reactant. uh, we are going to vary and form the product. ಏನೇನ್ changes ಆಗಿದೆ, we are going to study that. That is with respect to thermodynamics. Whatever the physical properties we are going to study when the reaction is taking place, whether it is affecting the system or it is observing by the system, it can be studied. So that is with respect to thermodynamics. Also, you go through this derivation, mathematical terms, by keeping constant pressure and constant volume. So these relationships are valued for ideal gas behavior, where R is the universal constant. And next important terms, the that is second law of thermodynamics. The second law of thermodynamics, which helps us to understand the direction in which the energy can be transferred. So it helps us to predict whether a chemical reaction can occur spontaneously or not, whether the reaction is taking place spontaneously or non-spontaneously, that it can be studied. So the work can also be converted into heat, but the conversion of heat into work does not take place under all conditions. Here, the second law also deals with the concepts of entropy. What is entropy? Entropy is the measure of amount of disorderness in a system. Whatever the changes taking place inside the system, that can be measure, that is denoted as entropy. Entropy is denoted by symbol S. So it is impossible to construct heat engine which is operating in a complete cycle. So in this second law of thermodynamics, it helps us to understand whether the direction in which the energy can be transferred, whether the reaction is taking place spontaneously or non-spontaneously, that can be studied using the second law of thermodynamics. So next, what are the concepts of entropy? The concepts of entropy andre, so entropy is the quantity in which tells us whether a chemical reaction or physical change can occur spontaneously in an isolated system or not. So entropy is the quantity which tells us, entropy is the measure of amount of disorderness in the system, whether the reaction is taking place spontaneously or not, that can be studied using the entropy. That is the entropy. So ds is equal to dq reversible by t. ds is nothing but the change in entropy, or s is the entropy. Delta S andre the change in entropy, whatever the variations taking place when the reaction is taking, the reaction ಆಗ್ತಿದೆ ಅಂದ್ರೆ whatever the changes it is taking place, it can be denoted by delta. ds andre delta S is equal to the change in entropy. Delta S is equal to dq by t. dq is the amount of heat absorbed by the system. So whatever the heat absorbed by the system, that can be represented as dq by temperature. So temperature can be measured in form of degree or Kelvin. So next is the physical significance of entropy. In the physical significance of entropy, entropy is the physical quantity. It remains constant if the substance undergo a reversible adiabatic compression or expansion. So whatever the reversible process it is taking place, it will be of constant. A to B, A forms the product B and B forms the product A, and it is in the reversible. So even the entropy will be of constant. Next, silent features of entropy. What are the silent features of entropy? Andre, entropy defined as microscopically is the same as one defined in the macroscopic form. So entropy is a state function. It is also a state variable. Means it can be varied. Here, whatever the variations, it can be denoted by delta S. Delta S is equal to S2 minus S1, which not depends on the path from state 1 to state 2. So whatever the entropy is changing take place, it not only depends on the reaction of the system. So delta S is equal to 0 andre entropy is in constant. So next important term andre, here one more derivation, they are derived the combination of first law and second law. So in the first law, delta Q is equal to delta E plus delta W, where delta Q is the amount of heat absorbed by the system, is equal to delta E plus P dV. That is the equation 26. From mathematical second law, delta S is equal to delta Q reversible by T. That is the the amount of heat observed. So that is the Q. So from that, from a combination of first law and second law, we can derive that is T delta S is equal to delta E plus P delta V from the equation, the 26 and 27. So 26 and here 27. From first and second law, it can be derived T delta S is equal to delta E plus P dV. This is also important term. And concepts of fugacity. So fugacity andre, it is an effective potential pressure which replaces the mechanical potential pressure. So whatever the pressure, it is respective of fugacity. Yeah, fugacity is a pressure like quality that is used to treat free energy of non-ideal gases. So it is with respect to pressure. The fugacity is defined as effective pressure having dimension of a pressure and is given by a expression of fugacity, that it is F is equal to psi of P, that is the equation 30. So here by applying Gibbs free energy is denoted as G is equal to H minus Ts or T delta S. G is equal to Gibbs free energy. H is the enthalpy of the system and S is the entropy of the system. So further G is equal to E plus P V minus T delta S. So wherever the delta G is equal to delta E plus whatever the changes taking place, that can be denoted by delta. Delta G is equal to delta E plus P delta V plus P delta P minus T delta S minus S delta P. So T delta S is equal to dE plus P dV. So where temperature is kept constant andre T is equal to 0 ಆಗುತ್ತೆ. So that can be denoted as delta G is equal to V dP. So if ideal gas is kept constant, that will be of 0. Same with respect to volume. So here G is equal to RT ln of P plus C. So C is the integral constant and G is the molar free energy of the gases. This is the molar free energy of the gases. G1, G2 are the molar free energy of the gases of state 1 and state 2. So that can also, it can be varied here. Delta G is equal to G1 minus G2 RT ln of P2 by P1. So next, significance of fugacity. So consider liquid which is in the equilibrium with its vapor mu1 is equal to mu V. Mu L andre that is with respect to liquid. The fugacity of liquid is equal to fugacity of the vapor. So mu is nothing but the chemical potential. So whatever the mu is represented as chemical potential. F is denoted as fugacity. So here the molecules of liquid tends to escape into the vapor pressure, vapor phase, and the molecules from vapor phase tends to go to back to the liquid state. So whatever the variations from liquid to vapor and vapor to liquid that can be studied here in the fugacity. So that is the equation where mu is equal to RT ln of F plus C. For two different states, we can also calculate the potential of that. So of state 1 and state 2, mu1 of RT ln of F1 plus C and mu2 of RT ln of F2 plus C. So mu2 minus mu1 is equal to RT ln of F2 by F1. That is the equation 45. So that continuously they are taken. So equation, but 1 to 3 can label that. And spontaneous of entropy and enthalpy. Here the two factors which determine the thermodynamic favorability of the spontaneity, that is enthalpy change and entropy change. So enthalpy change and the sum of internal energy, pressure and respective volume it changes. And entropy is the measure of system's thermal energy per unit temperature. So enthalpy change ಅಂದ್ರೆ whatever the enthalpy changing within it can be denoted by delta H. Delta H reaction is equal to summation of delta H naught product minus delta H naught reactant. So whatever whether is with respect to temperature, ಎಂಥಾಲ್ಪಿ ಪ್ರೆಷರ್ ವಾಲ್ಯೂಮ್ ಎಲ್ಲಾದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಅಂದಾಗ ಪ್ರಾಡಕ್ಟ್ ಮೈನಸ್ ರಿಯಾಕ್ಟೆಂಟ್ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಆದಾಗ ಏನ್ ಬಂದಿರುತ್ತೆ ವ್ಯಾಲ್ಯೂಸು ದಟ್ ಮೈನಸ್ ರಿಯಾಕ್ಟೆಂಟ್ ಇಫ್ ಯು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಯು ವಿಲ್ ಗೆಟ್ ದ value of pressure, value of volume, value of temperature, all the things can be calculated after the completion of reaction. In changes agide that can be calculated by product minus reactant. So this is the basic concept. And next, delta H reaction is less than 0, the reaction become exothermic reaction. If delta H X is greater than 0, by this also very important, whether the reaction is in exothermic or endothermic. So it can be calculated using enthalpy. So enthalpy, we are going to calculate delta H andre product minus reactant. So delta H is in the less than 0, then it is an exothermic reaction. If delta H is greater than 0, that is in the endothermic reaction. So here the entropy changes. When the entropy change can also be calculated. So that is delta S system, delta S reaction or a system or a reaction is equal to summation of S product, S not product minus summation of S not reacted. Whatever you need to calculate enthalpy, entropy, no product minus reactant, product minus reactant. The values you are going to take. Here also delta S is less than 0, the process in which the final condition is more random and in the initial condition. If the delta S is uh, less than 0 for a process in which the final condition is more orderly. So entropy is 0 ಅಂದಾಗ. So this is not enthalpy. ಇದು ಎಷ್ಟು ಇದೆಯಲ್ಲ ಇದು you correct it. This is an entropy change. So whatever the entropy, S is denoted by entropy. And if delta S is greater than 0, the products are more random state, are going from solid to less or in less orderly state, gas state. Increases in temperature, solid dissociating into ions upon dissolving. So delta H, when it is increasing, these are the reactions which is taking place inside the system. So also we can calculate whether the reaction is reversible or irreversible or spontaneous process. The reaction also can be checked whether it is in the reversible or irreversible, and spontaneous or non-spontaneous can be checked using the equation delta S is equal to 0 when the entropy is 0. So whether the reaction here, whether the reaction is in spontaneous or non-spontaneous and cyclic process or reversible or irreversible can also be checked. And next, so it's more than 1 hour. So next important topics I will go through is and entropy of the probability here. So change probability andre it is the chance of work done. So maybe work done. So entropy and probability andre it is the chance of work done by a system. So here system tends to change spontaneously from order state to disorder state, and becomes disorder states have much higher probability than order state. So whatever the entropy or knowing the what is entropy. Entropy is the measure of amount of disorderness in the system. Probability andre the chance of work done. So probability can be denoted by W and entropy denoted by S. So S is equal to minus K ln of W. K is nothing but Boltzmann constant. The melting of ice and evaporating of water proceeds spontaneously in direction of greater randomness, and hence entropy changes. So melting of ice into water and water gets evaporated. This will be in the spontaneous in one direction, but it is having lot of randomness. Ala. So This is with respect to entropy and probability. Entropy change in an ideal gas in different process. So that is with respect to isothermal process, isobaric process, and isochronic process. Whatever the entropy changes taking place inside the system, the randomness taking place inside the system, it can be studied by varying different process. That is isothermal, where temperature is kept constant, isobaric process where pressure is kept constant, and also with respect to isochronic process where the reaction is kept constant. So entropy change in ideal gas where isothermal process ಅಲ್ಲಿ where temperature is kept constant. T2 and T1 will be equal. T2 ಅಂದ್ರೆ the temperature which formed on the ಪ್ರಾಡಕ್ಟ್ ಬಂದಾಗ ಟೆಂಪರೇಚರ್ ಎಷ್ಟಿದೆ ಅಂತ ವಿಲ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಅಲ್ಲ, ದಟ್ ಈಸ್ ಡಿನೋಟೆಡ್ ಆಸ್ T2. ಅಂಡ್ ದ ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡ್ ಟೆಂಪರೇಚರ್ ಇನಿಷಿಯಲ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಎಷ್ಟಿದೆ ಟೆಂಪರೇಚರ್, ದಟ್ ಈಸ್ ಡಿನೋಟೆಡ್ ಬೈ T1. ದೇರ್ ಇಸ್ ನೋ ಚೇಂಜ್ ಇನ್ ಟೆಂಪರೇಚರ್ ಅಂದಾಗ ದ ಟೆಂಪರೇಚರ್ ವಿಲ್ ಬಿ ಕೆಪ್ಟ್ ಕಾನ್ಸ್ಟೆಂಟ್. T1 and T2 will be of 0. That can be seen here. So same delta S T is equal to Cp x naught plus R ln of P1 by P2, where pressure, where temperature will always 0. P1 V1 is equal to P2 V2, and delta S T is equal to R ln of V2 minus V1. So whatever the entropy changes taking place inside the system can be checked using the temperature kept constant. Isothermal entropy change of an ideal gas in an isothermal process andre should be knowing entropy change of an ideal gas in isothermal process. Whatever the entropy changes, we're keeping temperature constant. And next is the entropy change of isobaric process andre where pressure will be kept constant. P1 and V2 will be 0. For the same equation, we are going to put 0 for pressure. That is the isobaric process. Next is the entropy change of an ideal gas in isochronic process where volume is kept constant. So whatever the reactants that we are taking, that volume will be kept constant. That is the isochronic process. V1 and V2 will be of 0. And next topic is the absolute entropy and standard absolute entropy. So standard absolute entropy andre the sum of all entropy it would acquire on warming from absolute 0 to the particular temperature. So from 0 to particular temperature, that can be denoted as standard absolute entropy. So here it depends on degree of randomness in a system and relative distribution of energy with respect to system. Um, Here entropy change with respect to 0 to certain temperature, that can be denoted as St minus S naught. So S naught is the initial temperature, initial entropy, and St is the uh, entropy of final product form. So whatever the temperature increased with respect to entropy when the product is formed, that can be denoted as St. That is the absolute entropy. S andre it's an entropy and St is the absolute entropy. And next is the standard entropy. So standard entropy it can be denoted as delta S naught. So here, when the reaction involves the reactant to form the product in their standard state or entropy change, it's said to be standard entropy change, and it is represented as delta S naught. So delta S naught is a reaction is equal to CS naught into C plus DS naught into D minus AS naught into A and BS naught plus BS naught into B. So S naught is nothing but whatever S naught we are taken here. It is the standard entropy change. So S naught is the standard entropy change. N is the mole number of products and mole number of reactants. N and M. So whatever the product list ಇದೆ reactant form ಆದಾಗ ಎಷ್ಟು ಬಂದಿದೆ that we are going to calculate wherever whatever equation you are going to take same thing product minus reactant, then only we will get the values whatever the changes taking place inside the system, whatever after the completion of reaction, whatever the variables changes, pressure, temperature, volume, entropy, that can be studied. So here we are going to calculate one problem they are given here. Here we are going to calculate the standard entropy change for the reaction where nitrogen is hydrogen forming ammonia. So delta is not, that is of nitrogen 191.5 joules per Kelvin mole. So delta is not of hydrogen, that is 131.0. The formation of ammonia, that is 193.0 joules per Kelvin mole. So what is the solution? Solution in it's nothing but delta is not reaction is equal to product minus reactant. Product ಯಾವುದು ammonia, formation of product ಆಗಿರೋದು ammonia. So that minus reactant. So product ಬಂದಾಗ ಎಷ್ಟಿದೆ values? That is 193. 193 minus 191 plus 131. That is what they are done here. The value is minus 199 joules per Kelvin mole. Same thing they are calculated for the reaction of calcium carbonate. Next, here also we need to calculate the entropy, that is delta S naught. Delta S naught calculate ಮಾಡಬೇಕು. How you are going to calculate delta S naught ಅಂದ್ರೆ calcium carbonate ಎಷ್ಟಿದೆ that you are going to minus subtract the product minus reactant, that is 92.9 plus 39 plus 8 minus 213, that will be of 160 joules per Kelvin mole inverse mole. So in the next class, I will be discussing about concepts of free energy